Good afternoon. Now we'll begin the afternoon session of the two-day national seminar and Research Scholars Meet 2022. In this session, we have Dr. P.P. Pradyumnan, Department of Physics, University of Calicut, as the eminent person to deliver the talk, which is chaired by Dr. C.L. Joshi, Department of Chemistry, St. Thomas College, Thrissur. I invite Dr. C.L. Joshi to invite the eminent personality and begin this session.
Thank you. A very good afternoon to all. First of all, I am very much grateful to the organizers for giving me a chance to chair this session. The speaker of this session is Dr. P.P. Pradyumnan, Professor of Physics, Department of Physics, University of Calicut. He has done his MSc and PhD in Physics from the School of Pure and Applied Physics, Mahatma Gandhi University, and he joined as a lecturer in the year 1996 in University of Calicut, and later on he became the professor of this university. His areas of research interest is solid-state physics, condensed matter physics, material science, crystal growth, thin films, nanomaterials, and so on and so and so. He has 28 years of research experience in solid-state physics and material science, university level in India. He has also been a GCOE visiting researcher, Tokyo, Japan in nanomaterials, right from 2008. He has 25 years teaching experience in PG university level and 21 years of research guidance for PhD as well as MPhil. He has been awarded with the visiting research fellowship by Japanese government, and he is a referee journal of many journals, especially Elsevier, Springer, etc., etc. Presently, he is a member of Board of Studies in Radiation Physics of University of Calicut and also a member in Thermoelectric Society and International Nanoscience Community. He has 92 paper publications in national, international, and conference proceedings and 2 books published. He's a very good friend of me for the last more than 30 years, right from his studies as a MSc as well as PhD student. And he will talk on an interdisciplinary topic, mainly the clean energy materials for sustainable future. So he's a very good speaker, especially in the topic of material science, which will be useful for the students of both physics and chemistry and the other related students. On behalf of the organizing committee, let me wholeheartedly welcome Dr. Pradyumnan to this platform. Sir.
Thank you, sir, for a very nice introduction. Also, I thank all the organizers. Yeah. Can you hear me? Okay. Okay, it's audible? Audible? Okay, first of all, I thank all the organizers for giving me this opportunity, and I thank Professor Joshi sir for a nice introduction. Okay, today I am going to present my talk on clean energy materials for sustainable future. Let me to present my slides. Okay.
Sir, are you facing any issues regarding the presentation?
Yeah, I am finding some parent screen is not working. I don't know why. Okay, application window. Okay, then I think can you? Okay, is it okay now? Okay, is it full
No,
screen?
yes, yes, sir. It's visible.
Yeah.
Yes,
Okay,
sir.
okay. Okay, thank you. Now the slide.
Yes,
I
sir.
think you can see my slides. Clean energy
Okay.
materials for sustainable future. Okay. Why? Because now everyone is thinking about a very good quality materials and also energy. What we are using should be very clean and environment friendly. So in that condition, you know that the development of any country and any society is mainly depends upon what type of energy materials they are using and also how that energy they are utilizing and also how these energies are producing, and if it is very clean or it is good for the society or environment, at the same time the pollution free energy production is very much important, and also it is to keep our earth clean, and that is the main thing now everyone is discussing, because after Kyoto Protocol and everything, people are thinking about how to use clean energy and how to make our future very green and clean. So why sustainable future? So you know that economy, environment, and social community are three pillars actually of the development. So for sustainable development, you know that this should be a very hand in hand movement, then only this will be very okay. So the goal of sustainable development is to meet the needs of today without compromising the needs of future generation. This is very very fundamental, because not only the physics people or chemistry people or environmentalists, this is now the aim of all type of researchers working in the field of energy as well as in the field of technology. So we know that the rapid economic growth and industrialization lead to the exploitation of natural resources. Because for last 100 years, mainly the development in our society came into last 100 years, I can say. Because after the invention of invention of dynamo and the electrical energy mainly people are using, then these things happen, because initially many of the many of the generators of energy generators are based on coal and other fossil fuels. So now also almost all power plants are working based on coals. So that is why when you burn coal, a large amount of greenhouse gases will produce. So these greenhouse gases making problem, because global warming and also the climate change, everything is based on the amount of these greenhouse gases like carbon dioxide and carbon monoxide, etc. So that is why people now thinking, how can you reduce the fossil fuel utility, and how can we reduce the fossil fuel usage in our future and current needs. So concern of exhaustion of these natural resources, another thing. So because you know that mainly coal, petrol, and diesel, all these things are oil, crude oil, etc. Are we are taking from our own Earth planet Earth. So that is why this may be exhaust definitely if taking again and again, because our blow it will exhaust once. Then what will do? That is the another question. And at the same time, we have to maintain the balance of the earth, because if you are using more and more these coals and coal yards and quarries, then that itself creating environmental difficulties, because that is happening in Chile and some other China and many and Africa, where these coal mines are there, and in India also, in Bihar and many places. Right? because we are, and you know that oil mainly we are concentrating at Gulf and America. In that region also, people are saying that if you are you exploiting more and more this earth on energy, then definitely that again creating problem other than environment, what we discussing about the greenhouse emission, etc. In the process of economic growth, we know that damage is being caused to environment and ecology, which ultimately will create insecurity of human beings. This is the main thing now people are discussing, how to reduce fossil fuel usage, how to reduce the digging of oil, and can we use other thing to meet our energy utility. So we know that our country, because I already discussed that the development is mainly depends on the energy consumption of a country. So how much percentage of energy they are utilizing, how much amount of energy per year and per head a country is using. Based on that also we can calculate the growth rate of that particular country. So when we look into our country, the consumption, how what type of consumption is there? Petroleum, natural gas, coal, electricity, non-conventional usage. These are the different area of energy we can use, because India now also using about 48 percentage of energy mainly from coal. You know that we have very good coal quarries in our northeast and as well as northern part of northeast part of India. So we are getting enough amount of coal, and that is the reason people are using coal mainly. And natural gas also in some area we are getting, that is less than 7%, nearly 7% we are utilizing that. But next 26 percentage of mainly based on petroleum and petroleum products, that mainly automobiles as well as certain diesel power plants are there, or are based on petroleum, means petroleum products we can say. Natural gas we discussed, then coal, then pure electricity means hydrothermal electricity wise, that mainly. And non-conventional, about 14% we are now in India. It is actually 2020 that survey report. There only uh, about 14%. So that is not a bad thing, but now also we are thinking about how can we increase this to a 50%, because this non-conventional energy sources, and that is the main thing, and also solar cell and other things are coming into picture. So release of greenhouse gases like carbon dioxide into the atmosphere, resulting global warming, that we everyone is now it is okay. It is because of carbon dioxide this global warming is there. Almost all studies are okay correcting that it is not other thing, because the number of trees and also the forest in the all over the world is decreasing. At the same time, the carbon dioxide production is becoming more. So the first remedy for reducing greenhouse gas is definitely we can increase forestation. But of course, you know that the forest in our earth is diminishing drastically. So forestation at the same time, can we reduce the carbon dioxide production? Then we can balance somewhat global warming. One thing. But of course, for development we need energy. So how to reduce environmental pollution? So their question arises, atmospheric carbon dioxide ppm level slides are you are getting from internet. So climate central that they given up to 2020 data, and global warming also studies up to 2020 data is given in this picture. So here we can see that the global warming and environmental degradation demanded substantial efforts in developing sustainable energy sources. Okay. So what are the energy sources we can utilize for the development of a country and for our utility? So we know that there are many conventional methods are there, non-conventional methods are there, or non-renewable energy and renewable energy classification is there. So in this non-renewable energy, we already discussed oil, coal, and nuclear and natural gas. These are the non-renewable class of energy production. At the same time, renewable energy, there are many, but we know that enormous amount of heat energy is liberating from industries, automobile engines, and many other places. And even very sunny days, we are getting enough amount of heat energy. But all these energies are waste because we are not utilizing for our purpose. Okay, of course, we are using for drying meat and fish, etc. by using sunlight. That in former years and ancient times itself, people are using. But even though for the production of energy like electrical energy production, we are not utilizing this heat energy as well as very few amount of sunlight also we are using for solar cell application. But there are many, and wind energy, because in the country like ours and many country in European countries, they are getting enough amount of wind energy because this wind is a particular speed, then only we can utilize for energy application. That we are getting in our in Tamil Nadu and as well as in southern place of Kerala and some regions around Palakkad, where wind energy or wind power is sufficient for using or producing electrical energy. So that also we are not exploiting for an industrial manner, very, very low amount. And hydropower, of course, that is the main thing everybody is using in India and also in a country like Canada and other places and many places by using hydropower. Of course, that is the very clean energy source people are using everywhere. And another is solar, because you know that solar energy is our earth is because of sun. So this energy mainly we are getting sunlight radiation. So in Kerala or in India, we are getting most of the time in all over, per year a very good sunlight we are getting. So the sunlight, this particular energy we can use for electrical application or producing electricity. Then it is we can use maximum. That is the people now thinking. Can we use maximum, because KSCB now thinking about a rooftop solar panels. If you fix and then energy if somebody is giving to them, then definitely they will reduce the charge of our electricity. That is another project of KSCB. Now I think again they call for rooftop these type of solar energy systems. Okay. So then geothermal. Another is some area we know that very hot water is coming out, very hot spring we get. So that also we can utilize, because energy is hot water means that is energy. So that is another method. And of course biomass, because enormous amount of this biomass is available on earth, we can use that biomass for energy production. So these are the main two things: renewable energy type and non-renewable energy classes are there. We can be utilized for energy, to meet our energy uh, application, energy usage. So why solar energy people are now also mainly concentrating on? Because solar energy is the main component we can exploit very easily and for our electrical energy applications. So energy is incredible. And one calculation exactly saying that 30 days of sunshine striking on the earth have an energy equivalent to the total of the planet's fossil fuels, both used and unused. So you know that such an enormous amount of energy we are getting day by day, but most of these energies are underutilized or unutilized. The most advantage using solar energy is that this is distributed over a wide geographical area. And developing region like ours, India, have access to electricity generation at a stable cost for long-term future. That is another advantage for us because we have very hilly areas and other places. That area, very small solar plants are there, then we can utilize northeast and other places. Now also people are doing that, but we can more and more such plants are there, then we can reduce the usage of fossil fuels. And the main thing is silent and non-polluting is the main advantage of this type of plants. Using solar cell or photovoltaic cell, we can convert light into electric current very easily. So such material, now also you know that the efficiency of solar cell is very low. But even though the freely available sunlight we are using, so uh, that is not at all a problem of efficiency can be discussed here. As the geographical location of India falls in tropical region, we know that the generous amount of solar radiation all through the year we are getting. And in our state-wise calculation, when we discuss the uh, certain regions, you can see that very reddish color and light orange color. It depends upon how much energy, how much wattage are available in that region. So in we are using the solar power capacity we are using. But you know that even Kerala very poor, Kerala Tamil Nadu is not using much solar plants. But the region like Rajasthan and because they are getting very good sunlight at that region throughout the year, so they are using many very high solar power plants are there in Madhya Pradesh, then Rajasthan, Gujarat, that area. Maharashtra also they are doing, but you know that depends upon these around 1,000 megawatt to 1,300 megawatt power stations are nearly in Rajasthan and Gujarat, and some other areas very low in certain regions like Telangana. They are not at all using the solar plants now also. So we have to do more in that area to reduce the usage of fossil fuels. So I think this is an interdisciplinary talk, so I am not concentrating much on physics, but anyway, I will give some thing about what we are doing in our university, some work, some research work, what we do at the end. But here also I am discussing some physics, but not in deep manner or research manner. So you know that solar cell in anywhere in rooftop or where a solar plant is there, then you can see in Kerala. You know that our Nedumbasseri airport is completely uh, energized by solar plants. So solar cell they are using, and they are saying that the total amount of electricity they are utilizing from that plant only, and excess amount they are selling. So what are the main some physics I'm discussing here. You know that a solar cell is mainly now also manufacturing with the usage of crystalline silicon. So production of crystalline silicon itself a very big task, and pure silicon are using now by doping P and N, because you know that it is a solar cell is a diode structure material, P-type and N-type semiconductors together in there. So that is a diode actually. So, and when the sunlight is incident on its surface, material surface, electrons are generating. These electrons we are tapping out. The flow of electron is electricity. That is the simple physics behind this particular process. So when these type of materials we are preparing or solar cells are fabricating, then you can see a junction will be there and P and N are type materials are there. There may be a junction between these two. And when you know that the surface of all the solar cell, when we look into it, is very shiny. It is means that a coating is over the surface of the solar cell, because if there is no coating, the solar cell will corrode very easily, even though silicon, but surface will corrode. So for that, we need a coating on the surface. That coating is a transparent conductive coating. So transparent conducting coating is actually helps to both ways. One is that reduce the corrosion. At the same time, it is a conducting part. Surface conduction is happening through it, and also it is transparent. The maximum amount of sunlight is passing through the cell or surface of the material. And another thing is, when this light is incident, when sunlight is incident on solar cell, there may be reflection from the surface. So that reflection have to avoid. Then that is why an anti-reflection coating, because if incident sunlight is reflected, you will not get enough energy for the production of the electrons, free electrons. So if the photons are reflecting back. So that is why anti-reflection coating, transparent conducting on the surface, then an anti-reflection coating is also there. And the junction between semiconductor materials of opposite sides are there. So that region you can see how these things are. The anti-reflection coating and top transparent coating, then anti-reflection coating and junction framed in between them, and semiconductor material of the P-type may be opposite side, and bottom there may be a top and the bottom electrode will be there. Top electrode means transparent conducting oxide will act as a top electrode. Okay, transparent conducting coating material. Okay. So this is the simple thing, and here it is a magnified thing we discussed here, how a solar cell look like, and cross section of the solar cell is here. You can see that there may be a PN junction, and negative, these grids are there. Grid are actually collecting the electrons coming through. Sunlight when incident, of course electrons will pass through. These electrons we can take bottom, this, and the top is there. Then you are getting the electric current, simple way, and that we can charge a battery or another cell, or directly we can use for application. So these are called, these type of energy generation we commonly call, these are eco-friendly method for generating, because here no chemical reaction is happening. Only physical things are happening, because when photons incident and photons have sufficient amount of energy, then only these electrons will generate it. Otherwise, the material will be heated up. That electrons carry, and that flow we are using, that electrons flow is actually electricity, current. So then initially only one type of solar cell we discussed, that is solar cell. Now also main economy of solar cell are from silicon solar cell. So classification of photovoltaic solar cell or common solar cell are there now, because initially photovoltaic cell monocrystalline solar cell, I already discussed the silicon preparation, crystalline silicon, because how to grow the crystal, because in 1950s actually. Before that the invention of transistors, at that time itself people need a very pure semiconductors. Then Chokralsky, a Russian scientist, he only came and forwarded a method to prepare very pure silicon crystals. His method is named after Chokralsky pulling method for fabricating silicon crystals. So that is a very tedious method. By using a very pure small seed crystal, and that seed crystal is uses for fabricating or growing very big crystal having meters of length and meters of diameter. So that technique is time taking and also need very good amount of energy. That is the reason solar cell becomes crystalline solar cell becomes very expensive. And for that we know that monocrystalline, because it is completely single crystal, because very huge crystal they are fabricating by using this Chokralsky pulling technique and properly doped while preparing it for the preparation of p-type and n-type. And they are monocrystalline means that they are single crystal throughout the specimen. Periodicity of silicon atoms are similar. There may not be any grain boundaries. Grain boundaries are there, their physical property may be different. So that is why monocrystalline solar cell are very good and their efficiency is comparatively better than other type of crystalline silicons. So polar, the monocrystalline silicon and polycrystalline. Polycrystalline means they are crystalline materials, but the main thing is their crystallinity is even though throughout the specimen, but there may be grain boundaries and some regions periodicity may be different than its neighbors. So that is why the photovoltaic, the first generation of solar cell are coming from mainly silicon, and monocrystalline silicon and polycrystalline silicons are the first generation photovoltaic cells. When we go into second generation, there people discuss how can you reduce the cost of the production of solar cell. The amorphous silicon material, both p-type and n-type, they can fabricate. So amorphous silicon means the, because if fused silica when fastly cooled, then you are getting the amorphous silicon material. But that method is very simple, not that much tedious as we in the case of discussed in the case of Chokralsky pulling technique. But here, the amorphous silicon we are getting by the simple method. Only we are cooling silica, what we used in monocrystalline silica production is here. Fast cooling we can use, and that method we are getting silicon crystal which are amorphous in nature. Amorphous in nature means it is not, we will not get, when we take XRD, we will not get a crystalline peaks what we observe in the morning, in the case of polycrystalline or monocrystalline materials or single crystalline materials. There are another second generation class in silicon amorphous one is also coming under second generation photovoltaic solar cells. Cadmium telluride, cadmium sulfide class of materials are compound semiconductors. They are very good class of material. They are giving very good efficiency also compared to silicon. The only problem is they are compound semiconductors and their durability compared to silicon is not that much good. But of course, the preparation wise, it is very simple. Then copper, indium, gallium, diselenides are another class. They are very easily one can prepare a foldable or thin film like material by using these class of materials by spray method or spin coating method, etc. That is why, and these methods become very popular, and at the same time You know that almost all very small toys with solar cell Chinese uh, toys are made up of energized by using these type of very simple solar cell materials. And third generation, because you know that currently third or fourth generation solar cell now people are discussing, but third generation photovoltaic cells, copper zinc sulfide are there, copper zinc tin sulfide. Then another class of materials are dye-sensitized photovoltaic cells. People are discussing about it. There are many application and sensor application etc. are discussing. And organ, because I'm not giving a detail because it's an interdisciplinary like thing. So I'm not into deep of each one, but only I will discuss some more in thermoelectricity. There I will deeper one. But I'm here. I'm not going to Dyson solar cell, and you know that organic photovoltaic cells. There are many people are discussing about organic photovoltaic cell. Maybe they are semiconductors. They are very good, and naturally they are not creating any problems. That's why many are now discussing about organic photovoltaic cell instead of inorganic. Then another class of materials is now people are mainly discussing about perovskite. Perovskite are a class of material based on the crystallization or based on crystal structure AB2O3, AbO3 like structures. AbO3 structures are commonly coming under perovskite, and they are as you know that AB2O3 and AbO3 like structure, they're mainly uh, superconducting material like strontium, barium, copper oxides, etc. They are also coming under perovskite. Similarly, those type of structure have some role on the creation of free electrons very easily, and that is another thing. Now everybody is discussing about can we use oxides for photovoltaic applications and sulfides like the having this particular structure. And now you can see many projects are there on perovskite solar cells. And another class is, as we discussed about organic photovoltaic, polymer photovoltaic cells, quantum dot photovoltaic cells. Because these are another class now when we are discussing about compound solar cells. At the same time, polymer materials, polyaniline like materials doped with certain kinds of nanomaterials and quantum dots, you can make that material highly efficient solar cell materials. That is another class, quantum dot photovoltaic cells, cadmium sulfide, cadmium telluride, indium selenide, like classes now everyone is discussing. And if this type of structure is there, the density of states and etc. may be different. So that is why their efficiency may be increased drastically than other crystalline solar cell. So that is another thing. So solar cell now everybody is discussing because the utility is that much enormous. So telecommunication, of course, we need energy because solar satellite is there. Definitely, we need solar cell for energy production. Without any solar panel, we cannot send a satellite to our Earth's orbit because the energy source is sun or sunlight. Then everywhere this solar application may be there. So mainly for battery charging and day and night, and now railway signals, battery charging stations, solar lanterns are there for remote areas for energizing houses or electrifying houses in hilly areas where we cannot put all the posts and making that area electrified. So in that region and also in Africa, in many places in Antarctica, where sunlight getting, then of course we can use the solar cells. for electricity generation. So photovoltaic integrated building are there in many buildings in China. They are already used photovoltaic integrated building to reduce the energy crisis. Okay. Then domestic lighting system will be there. That lighting system also certain houses when while building itself, the roofs are made up of solar cells, and in that way, while making itself, they can reduce the energy application, energy usage of that house. So another thing is wind energy. Wind energy is also we can call it is clean energy. But where how can say that material? Because here very similar to wind energy, we are using a turbine. So when this turbine is rotating by the flow of or by wind power, then that is mechanical rotation. Definitely that maybe by using certain gearboxes, we can control or we can enhance the speed of the turbine or generator, and that is the simple technique here using. Similar to because similar to hydrothermal project, there we are using motors or generators, and here similarly here turbines are using this turbine will rotate, and by using proper gearboxes the speed we can reduce, we can increase. That high speed rotation will give the when Faraday's Faraday's law application applied, and for proper generators are there. That generator will give you the power output. That power output you can use for application. That is the thing here. Wind energy utility very simple and at the same time very cost effective. If such very huge these plants are there, the using wind turbines, kinetic energy of wind is converted to mechanical energy or electrical energy that can be harnessed for practical usage. And here requires less space than average power stations. And you know that in certain regions, very huge number of in Europe also you know, in Tirunelveli, that area when you are passing, you can see these type of wind energy or wind turbines are there. There they are using the wind energy or plants are there in Tamil Nadu, in Tirunelveli, that area you can see these. And we can combine okay, then now people are saying that wind energy and solar energy combination we can do in certain regions, because in the night time very good wind flow will be there, and in the daytime very good sunlight is available. So the same region we can use for both. So that type of plants are now people discussing for how to reduce the carbon dioxide greenhouse emission. So another thing for generation of clean energy is, of course, that is the not a new thing, but of course batteries. So everyone is now discussing about battery. Now lithium ion battery, people everybody is discussing. So polymer battery. So mainly after the invention of these mobiles and laptops, where we need a huge amount of this energy, mainly storing electrical energy. But before that, we can directly pin and use electrical energy, more electrical energy. But when we want to transport our knowledge from one place to another, simple technique is, of course, mobile and laptops are there. So there we need the storage of electricity. That is why very small and thin battery required. So it is definitely a transducer which convert chemical energy to electrical energy and vice versa. But when we charging and discharging, of course, that charging discharging is the main thing when the lithium ion is discussing. But now also you know that cars are there for car and vehicles, automobiles are run by battery. That is why the research in this area now spending a lot of amount how to increase the capacity of batteries and life of chargeable batteries. And is there any possibility of directly using the solar cell and this thing? Because the when vehicle is traveling, you know that maximum energy storage we can do by solar cell together. That type of research is going on. And of course, anyway, these all help for our clean earth, our clean, are coming under clean energy, of course. The main thing is when we discuss about these type of batteries, high energy density is another thing, and high voltage can we do, and how much shelf life, because once you charge and keep for long period, that's the main advantage of this. If it is the shelf life is not very high, then definitely the usage and how much year you can keep after charging a battery, or we can keep as a stock one, or a, that is why long shelf life is required for this type of batteries. So you here you can some chemistry or physics I can discuss here. Here is this is schematic representation of lithium ion battery, lithium ion cell. Here, uh, charging and discharging, you know that these batteries are commonly used for charging, and then that we can discharging means we can use for our application. So these type of compartmentalized structure we can see in, but it is a very simple schematic diagram. But of course, you know that ions, ionics are there. Lithium ion phosphate cathode is there, and graphite anode now people are using, and membrane electrolyte is there in between them. That membrane is also pass the ions from one place to another when charging and discharging. That depends upon how many concentration of depends upon concentration of ions from one to another through this membrane. So this membrane itself is very expensive, and that is the main thing. Now people are discussing it's a polymer, particular type of polymer. So lithium ion polymer battery are now everybody is using for mobiles and laptops, etc. And polymer batteries are there now, very thin polymer battery are there, and their life also, the charging time, etc. Now day by day they are increases by using proper membranes as well as proper anode and cathodes. And another clean energy thing source is hydropower, because this is very conventional. At the same time, hydropower plants helping us for getting very clean, and it is also multi-purpose. We can use, and from this itself, we can say that tidal energy usage is there, dam and then hydropower usage, wave energy, oceans, uh, etc. are there uh, along this. We all are associated with water, and tides means tide itself a power, ocean. That also another method, and there are also some research is going on, but it is not 100%. This tidal energy utility is not 100% successful, but in some European countries are successful in that area. But in India, we are not using some power plants we studied in Virginia, but it is not working now. So geothermal is another class of clean energy application. Geothermal energy is also a type of renewable energy taken from Earth's core. Earth's core is, you know, that core is contained magma and high temperature. So this is the schematic diagram that you can see. Here, a cold water pumped down through a particular canal or column, and it is passed through on the, because it is passed through on in this area, and then water is completely heated up, and that heated water we can taken out by another part, and that heat energy we can use for other our application. So this is generating geothermal. That's why it is called geothermal energy. Geothermal energy is a type of renewable energy taken from the Earth's core. Geothermal reservoirs can be suspected where we find geyser, boiling mud point, volcano, hot spring, etc. are giving good amount of heat energy. That heat energy we can use for heating water, and that water we are using for tapping energy or generating power by using that steam. Water means here hot water turns to steam. Now we know that everywhere when we discuss about another clean energy source, we know that almost all automobile engines as well as industry etc. are uh, expelling enormous amount of heat energy, and that heat energy directly can be used for any for generating electricity. That question arises because then people think about thermoelectric city and thermoelectric applications. So sustainable and green energy environment through waste heat recovery is another thing, because these waste heat are there means scavenging waste heat or scavenging this heat into the useful electrical energy. We can say that that itself enhance the efficiency of any instrument, any if it is a car or it's a vehicle, its efficiency will increase when you are using the expelling heat from car for generating electricity, and that electricity we utilize for air conditioning the car. Then this may be more helpful. So here this the physics, simple physics behind it is, you know that then a heat source is here, that may be the heat engine of or engine side of car, and there p type and n type semiconductors here also we are using. From p-type semiconductor, these, you know that holes are there. These holes will be, when heat energy is there, then these holes will be moved from here to hot to cold region. Similarly, here also you can see that these electrons from n-type also may be like this. There may be a, depends upon the type of this, there may be a flow of flow of charge. That flow of charge we can here negative and here positive. When you are placing a load here, then it will works. So that is the simple physics behind this particular phenomena. Here heat energy by using proper PN junctions or PN material junction, we cannot say PN junction, PN materials properly used, we can generate electricity. That is the simple thermoelectric module. So this is commercially now people are utilizing for both the purpose for generation of electricity as well as generation of refrigeration. So that is why thermoelectrics becomes now very popular, and everywhere people are discussing about how can we reduce the heat which are flowing out. Because you know that heat energy when flows to our earth or our atmosphere, definitely it will generate more and more greenhouse gases. So these greenhouse gases may again increase. So that is why reduction of waste heat itself a good method or good remedy to reduce the greenhouse gas. So thermal plant, power plant, nuclear power plant, automobile, waste incinerator, factories, and natural gas systems. Everywhere you can see that a huge amount of energies. So when we discuss about these heat engines, about 66 percentage of energy loss are in the form of waste heat. After running a car about 1 kilometer, you just touch the bonnet of car. Definitely, you can feel that how much heat is there. So 34 percentage of energy only we are utilizing. 30 to in between 30 to 40 percentage. About 60 percentage is underutilized or unutilized. And we know that Carnot engine efficiency is not high. So that is the reason why these are not working. These are not this amount of heat energies. These all are passing through the environment. This heat. So, electrical energy, and you know that thermoelectric materials enable direct conversion between thermal and electrical energy. That is the advantage of this technique. Here, we need new materials like solar cell. Of course, solar cell efficiency is now reaching to 20-25 maximum, but people are saying that up to 40 it is possible. But here also, you know that these we cannot think about the we can't think about the efficiency further, because efficiency is not at all a problem here, because these waste heat is we are scavenging waste heat. So the fundamental physics in this particular methodology of electric energy tapping is Seebeck effect. Seebeck effect, we know that the development of an electromotive force or voltage across the material in response to a imposition of a temperature differential. If a temperature gradient is there, correspondingly a voltage will be generated. And at the same time, you know that Peltier, he formulated that if a temperature differential is there, temperature differential caused at the junctions of dissimilar conductors with the passing of current, then that temperature differential may be there. Means in that method we can uh, generate low temperature at a particular point. So that is also possible. Seebeck, the vice versa of Seebeck effect. One is when temperature is there, different temperature gradient is there, correspondingly a potential created. Similarly, here energy by passing current, there may be a temperature gradient or temperature differential. Then another person, Thomson, because he formulated that rate of reversible heat, because heat passage, due to the passage of current along single conductor placed at a temperature difference. So that is also we are using in both here. So this is the simple physics behind the three effects are there: Seebeck effect, Peltier effect, and Thomson effect. These three are utilizing in these practical devices to generate the electricity. So these are the schematic diagram of modules, p-type and n-type, and then heat absorbed by some regions, then heat ejected through. Then the part is this part cold junction may be there and hot junction may be there. So these things of this type of electrical module we can generate by using proper p-type and n-type materials. That is why a very good amount of research work is now recently going, because this is not a new one but very old technique. But over the years, about 60 to 70 years, the research in the area is not that much good, because now again people are thinking about, because this how can we tap the heat energy from automobiles and other places. So advantage of this particular technique is this actually recycles waste heat energy. So that is why it is also coming under non-conventional energy sources. And another advantage is no moving element in these kind of materials when we use. No working fluid or gases is required. And there is no noise at all, because this type of when a turbine works, definitely huge amount of noise will be there. Even these wind plants and in that region, you can see a huge noise pollution will be there. But here it is proper semiconductor P and N like solar cell. There is no noise operation here. No greenhouse gas emission because here itself heat energy we are using. So greenhouse gas emission will be reduced. And reliability wise, it is also good because if a proper semiconductor we are using, then definitely this may be the durability may be very high. And thermoelectric applications. When application wise, this already started people like large company like DuPont and then automobile like BMW. They are searching and they used some small units in their car for a Peltier modules for generating uh, low temperature inside the car. And biological specimen keeping places the Peltier cooling of these methods using. And many food storages, there also this Peltier module, prepared Peltier module people are using. And of course, in extraterrestrial or interplanetary travel, their solar cell cannot be used for energy generation. Their radioisotope thermal generators are using for generating electricity for their as a fuel cell. So that is another main application of thermoelectricity now, interplanetary or intergalaxy in future maybe. There also the radioisotope thermal generators have to be used. Then and also now also watch driven by body heat because now we are using some lithium batteries are using in our wristwatches or chargeable batteries we are using in smartwatches. But now some companies like Psycho already started watch driven by body heat because you know that our body temperature is 37 degree. Then that temperature and surrounding may be lesser. So that temperature gradient itself is there. By using that gradient, we can generate electricity. That electricity we can store and utilize. That is the technique. By using proper thermoelectric generators, one can store that gradient, temperature gradient, and electricity generated due to the temperature gradient. So thermoelectric power generation, thermoelectronics we use in wristwatches, thermoelectric cooling we are using for food storage. We want to because of remote travel etc. There may not be any electrical energy, but so these type of and silent running submarines are another submarines already there by using the thermoelectric generators. And a climate control vehicle, that climate control application also these type of things are using. So I already discussed about the thermoelectricity used as radioisotope thermoelectrics used as radioisotope thermoelectric generator for aerospace missions. So aerospace missions, you know that here plutonium 238, that is a radioactive material. That radioactive material is keeping and it is at the center, and you can see that there are so many thermoelectric modules. That modules, when these emitting the radiation, that radiation may be uh, absorbed by or used by this particular unit, thin film material, and that may be converted into electricity. That electricity we can tap by using proper circuits. That is the method used for radioisotope thermoelectric generators. So here, this is commonly used for not in our common satellite. It is the like Voyager, like interplanetary missions and things only. These type of sources are using. Our common satellite, there are solar panels only using. And in car, of course, there are some already some works started by people, and There are also thermoelectric generators. I am not and also flexible. Now another thermoelectric application. Now people are discussing about flexible and wearable thermoelectric modules. So how can we, why these type of materials becoming important means, if we have any biological or some disease or any problems, then definitely the temperature in that region may be drastically changes. So if a temperature changes there correspondingly, when we place a thermoelectric film or thermoelectric material in that region, you can see a generation of thermoelectricity in that region when a gradient is there. So by keeping these type of taps or films pressing on the body part where this type of anomaly of temperature is happening, then by measuring that voltages, one can say about many things about if there is any chance of cancer cells in that region or any other anomalies are there, etc. Are now people sensing. I think recently one article, cement people discuss about the certain types of bras, thermoelectric bra used for finding uh, uh, the cancer, etc. Okay. So wearable thermoelectric modules are another. Now people are discussing about. I think that is another uh, application. So when we discuss into research in this area, we know that how to increase the efficiency of thermoelectric material. Is there any limitation? Here I am discussing only some more physics in this, some equations. I don't know how many physics people are seeing this, but definitely, or some chemistry and physics people knows this very simple equation. I am not discussing more in detail. So here efficiency of a thermoelectric material is determined by the dimensionless figure of merit, ZT. That is equal to Z is a constant. You can say that ZT is S square sigma T KL plus KE. Here S is the Seebeck coefficient, that is the constant, or we can say that that value is Seebeck coefficient of a material is dV by dt, change in voltage with respect to temperature. And sigma is the electrical conductivity of material and T is the temperature. And KL and KE are thermal conductivity, because you know that figure of merit depends upon Seebeck coefficient, conductivity of the material, and also the uh, thermal conductivity. Here mainly thermal conductivity due to electrons and phonons. Electrons, you know that K lattice plus K electron. Lattice means lattice vibrations. Lattice vibration when quantized, we call they are phonons. And Seebeck coefficient is commonly we call S or alpha, whatever may be. That is change in voltage with respect to change in temperature. Delta V by delta T. This is the simple equation. And how can you make or discuss about a good thermoelectric material or thermoelectric module? So here when we discuss large Seebeck coefficient material is possible or not, and high electrical conductivity, low thermal conductivity. These class of material, if you have, then definitely that material has very good application for in thermoelectricity. So for that, we need phonon glass, electron crystal-like material, or simply PJEC. Phonon glass, electrical crystal means large Seebeck coefficient material. It should have electrical conductivity. You know that most of the material having high electrical conductivity, they are very good thermal conductors also. Aluminum or copper, whatever maybe, they are good electrical conductors, and at the same time they are good thermal conductors also. But here we know we need a high electrical conductivity and low thermal conductivity. That is the main difficulty of this material. So Here, electron transport and heat transport, material physics together works for getting a good thermoelectric material. And these are the materials commonly used for these thermoelectric application. Their efficiency may be up to 17. People are saying that 17 or 18 they can get. The common material is lead telluride. That is initially people bismuth telluride. Again, most people commercially wise maximum utilized one is bismuth telluride. Then silicon germanium, scuttrodines, clathrate, half usular alloy. These are certain class of material. I am not going to the details of these. Then now the graphene, because this is the material people are saying the material of 21st century is graphene. So everybody is discussing about graphene, and now I think in Kerala there will be a graphene institute under digital university they started. So these graphene also have played a major role in thermoelectric materials. And here bulk materials I already discussed, and now foldable thermoelectric material people are discussing. Their foldable material, there are also some polyethylene terephthalate like material substrate, and their proper material if you coated, then thermoelectric behavior is there. These are one thermoelectric module, PN type module placed on a PET. So I already discussed these things. So what are the benefits of these devices? I already discussed. No moving parts, no working fluid, a low noise operation, and very very small size and weight. And reliability, some company like Cryotherm guarantees lifetime more than this much hours, about 2 lakhs hours uh, for their thermoelectric devices, and easy switching from cooling to heating problems. These are some citizens thermoelectric wristwatch, and this is thermoelectric air conditioning test for silent running submarines. They in USS Dolphin AGSS 555. These are some already commercially available by using this. This I already discussed about power generations for space vehicles. And now for material wise, figure of merit, I already show you that set T value. So what is the limit of the set T value, and how can you increase the set T value if there is any limit for this particular thing? So that again, there we discuss about phonon glass electron materials, PJEC like a class of materials. There the the these material comes into picture. So they are semiconductors. So thermoelectric materials, semiconductors are the most suitable thermoelectric material. Even though metals also produce thermoelectricity, but degenerate semiconductors are the most suitable thermoelectric material to get a figure of merit set T value greater than 1, or the aim of the value will be 4. Now people are discussing about if it is 4, then the efficiency will be very high, and for commercialization and other application 4 is good. But 1 is now reachable, and bismuth telluride like material showing a set T value of around 1. Square sigma by K value. Set T is equal to square sigma T by K. So this thermoelectric figure of merit value set is square sigma by K. That is set T is equal to square sigma T by K. Definitely that L is Lorentz number, that's a constant. I'm not discussing more in detail. So this is the reason because low thermal conductivity and high electrical conductivity achievable material is these semiconductors. So power factor square sigma. So now everybody is looking for the efficiency or the working feature of a thermoelectric material is depends upon S square sigma value of that. particular material we fabricate. So these are certain materials. Nanostructure. Another thing is we already discussed that how to reduce the thermal conductivity. One method to reduce the thermal conductivity is nanostructuring. So if a bulk material, its thermal conductivity is higher. If nanostructured, then we know that many scattering centers, and that enhance the it will not much affect on the electrical conductivity. At the same time, of course it depends, but at the same time thermal conductivity may be drastically different than its bulk counterpart. So this is the picture showing that by candle, using a simple candle, hit the one surface of this material, then LED is glowing. That is showing here. This is the method of thermoelectric generation. Now people are saying that okay, a hot surface, when you keep this particular module, definitely you can generate electricity. Such kind of many units are now made up of many different kinds of materials like lead telluride. Here you can see a large number of materials in this class. So here how to scatter more phonons. So that depends upon structuring. So we in our lab did some work on bismuth tellurides and antimony telluride, lead telluride, etc. There we nanostructure also we studied, and there we fabricated different kinds of thermoelectric devices, then cobalt, etc. So these are some thermoelectric materials, and of course there are so many physics behind it. I'm not giving all those details, but of course the density of states is very important parameter when we discuss about nanostructures and nanostructured thermoelectrics, how play a major role on the efficiency of this material. So here this is one of the fundamental thing when we discuss about nanostructured materials, how at density of states changes when the material is bulk or crystalline or three-dimensional material, and two-dimensional material, how that particular thing will be vary with energy or density of states how varies. And when quantum wire it is more precise, and then quantum dots it is again very much precise. So all these factors also depends upon when you are incorporating nanomaterial into the thermoelectric modules. So these are some examples of materials I already showed you, but this is a very good picture, a very good slide. Here you can see bismuth telluride, lead telluride, zinc antimonide, silver. All these are some classes, and oxides also play a major role on this. Another material we prepared is nitride-based thermoelectric materials. Here we prepared tin nitride and chromium nitride materials, and we prepared in both bulk as well as nanostructured, and also we prepared into thin film forms of chromium nitride as well as tin nitride, and studied their performances, and they also showing very high power factor, about nearly 400 or 350 power factor we obtained, and we published these results in very good Journal of Applied Physics, and also in Material Science Engineering B recently. These are some new thermoelectric materials we prepared, and we studied their thermoelectric features, Seebeck coefficient, power factor, and the class of temperature. This works very nicely is in between 200 and 240, because you know that this range is very much available in our automobile engines and other places. So if it is less than 100, then the material having showing very good thermoelectric property at less than 100 degree, because then we can utilize those kind of material sunlight heating. Okay, that is why people are looking for certain kind of material which are showing lesser than this. And another class of material is oxides, because oxide material, nitride of course good, oxide chemical waste, because they are not much harmful to environment. Oxides, chemical versatility, structural integrity, and offering a great flexibility of structural and compositional tailoring. Their oxides are another good class of materials, and low cost and environmental friendliness is another advantage of this kind of material. But the only problem is these materials having very low conductivity. So how can you increase? So if one has successful in increasing the conductivity of this material, this may be very good. We did some work in this, and we in films we by doping dysprosium in very standard zinc oxide nano materials, we found very good power factor. Not even though it is not very high, but of course it can be used for some sensor applications, so etc. And we also published this work. By, and tellurides, we in collaboration bismuth telluride by using carbon nitride properly. We almost graphene structured material. Now everyone is discussing about the graphene. So these we incorporated in. We did some collaboration with IAC, Professor Marjai, and with that we prepared a material, bismuth telluride and graphene structured carbon nitride. This is a bulk method, process method, and by utilizing this also we successful, and efficiency is, you know, that we already won, nearly one we successful in this. So one we also successful, but we are looking for more than that. The effective value, figure of merit value is nearly one for this class of material we have studied. So this is the work we did, oxide, nitride, and telluride. Okay, thank you for hearing my talk. So okay, I'm done. Hello,
Hello.
hello.
Yes.
Can you? Okay, okay.
Okay. I think.
I'm stopping my. Okay. I can stop my
Yes,
sharing.
definitely.
Okay.
If anybody has any doubt, you can ask.
I think I'm audible. I think any problem
Okay,
with
no
the
problem.
networking? No, no problem. Okay.
Okay. Okay. Thank you, Dr. Pradyumnan. You have a nice presentation of lithium batteries,
Uh,
batteries, and all related to thermoelectric power generation, etc.
uh,
Even your health
and
condition, you have continued till 1.5 hours on behalf of organizing the meeting. Let me extend my thanks to Dr. Pradyumnan. Thank you very much.
thank you, sir. Thank you all once again. So I can leave now.
Thank you,
Okay.
sir.
Anything more?
No, sir, it's almost done. Thank you, sir.
Yeah. Okay. Thank you very much. I'm leaving. Thank you. Thank you all.